So this is the final jump instruction, and it's called JUMPIF. So the instruction is given by 0101, and it will jump to an address which is contained in the next address of the RAM, only if one of these flags is set. So these flags come from the ALU. So this is a carry flag, the A is greater than B, A is equal to B, and the 0. So it will only jump if one of these is set, but we've got 16 possibilities here. So we could say that, for example, the first one here, well, the first one would be no jump, but the second one here would be, it would jump if the 0 flag was set in the ALU, and this one here would jump if the equal flag was set within the ALU, and this would jump if the equal flag was set or the 0 flag was set. So if we worked all the way down to the bottom here, we would have jump CAEZ. So that will jump if the carry flag set, or the A is greater than B, or A is equal to B, or the 0 is set. So really we're saying here, this jump command is, it jumps if these are set to an address which is given by the contents of the next byte of the RAM. So we can see here that this JUMPIF, it's really associated with the ALU instruction, because you'll go through an ALU instruction, and after the ALU instruction one of these flags will be set. If it's set, then it will jump to the contents of, it will jump to an address which is given by the contents of the next memory location in the RAM. So let's go ahead and we'll see how we're going to build this in Logisim. So if you go to the resources section, you'll see there's a file called JUMPIF instruction. So if you go there and open that up, and then go down to CPU, then you'll see we've got our CPU here. So let's get in and we'll have a look at that in some more detail. So you can see here that we have the CPU that we've seen over the last few videos. It's got all the same components, but in this instance here we have this extra component here, and this is the very last register that we're going to add in, and this is the flag register. Now whenever we do this JUMPIF, we're going to make a comparison, so we're going to see whether any of these are set. So we're interested in whether the carry out is set, the A larger, the equal is set, or the 0 is set. But now in order to do that, we have to have gone through an ALU instruction. So at a particular point of an ALU instruction, one of these would potentially go high. Now after the ALU instruction is complete, we want to go and do the JUMPIF instruction. But that means that the information that was here previously will now have passed on, and it would have gone out of the accumulator. So we need to be able to go and take a little copy, a little snapshot of these values whenever we go through this ALU instruction, and we do that here with this register. So all we do is we store these bits of information in 4 bits here in this register, and we set the information in that register from some point here. Now exactly where do we set this information? Well, we want to set the information in this register depending on something to do with the ALU instruction. So somewhere within the ALU instruction, whenever we have actually worked out an answer and just stuck it in the accumulator, at that point we want to be able to take a little copy of it. So in order to do that, we'll have to go back and have a look at the ALU instruction and find a place where we can take this output from. So we're going to do that just in a second, but first of all we'll have a little look inside this here. So all that is just our 4 bits, and you can see that's our latch there. So let's go ahead first of all and we'll go and see where we're going to get this set bit from the ALU instruction. So if you go to the resources section of this video, I've put a copy of the ALU instruction file down there just for convenience, so you can go and open that up if you like. And then if you get into CPU, and we'll look at that in a little bit more detail. So what we want to do is we'll get into the control section here. So this is our control section. We don't need to see all of it. We just this is fine for us at the moment. But what we want to be able to do is we want to make sure that we can take a copy of the flags in the ALU at the right point. Now the point that we want to take this copy is whenever the accumulator gets set and the accumulator gets set. So whenever that accumulator gets set, what we can do is we could take a little output here and we can connect a pin onto it. So that'll be an output pin there, and that would be our set pin. So we could take this output here and we could feed it into our little flag register, and it will take a copy of the flags from the ALU at the right point in time. So I never put this in originally because we hadn't talked about any of the flags. So if you go back down to the resources section and open up the JUMPIF instruction again, and then come down to CPU, so let's just jump into the control section first of all, and we'll have a little look, see how this is going to work. So this is our control section here, and you see I've stripped away the stuff that we're not interested in, so we're just left with the JUMPIF instruction. So you can see here at the bottom we have our carry, we've got our A is greater, we've got our equal, and we've got our Z coming in. And those are coming in and they're going through these AND gates here and then through an OR gate. Now these AND gates here, the other pin of these AND gates are connected to the first 4 bits, so this is going to be our carry, our A, our E and our Z for these 4 bits. So we can put in our code for our JUMPIF, so that's going to be 0, 1, 0, 1. So at 0101 we can see here that it goes through our 3x8 decoder. We've now working our way down this set of AND gates, so we'll go down to this AND gate here, and this AND gate comes up and it's going to get into 3 other AND gates. So it's going to get into this one here, and this one, and this one, and these 3 here are going to be connected to the steppers at step points 4, 5 and 6. So whenever the stepper comes along here and hits point 4, we're going to make this line live, and it's going to do this instruction address register enable, memory address register set and accumulator set, and also it's going to put 1 onto this bus here. And then we've got the next line 5, which covers this line here, and then line 6 covers this line here. Okay, so there's a few things here for us to work through, so let's go ahead and we'll work through and we'll see how this provides the JUMPIF. So let's pick a particular one of these we're going to set high. So let's say we're going to set the 0 high. So you can see here the 0 gets set high here, and if we were to have the 0 set high in the instruction, there you can see that that 0 is going to be passing straight through here, and as we said, it's either the carry or the A is greater or A is equal or the 0. So that's the OR gate for each of those possibilities, and those all go to this third AND gate here. So let's go up and first of all we'll just talk our way through the first step here. So let's say we get to step 4. When we get to step 4 we can see that this bus is going to go high. Now the reason for the bus going high is we want to put another 1 onto the instruction address register, because we know that whenever we work through this process 4, 5 and 6 and we get back to the beginning again, we want the instruction address register to point to the next instruction. But the next instruction, the next point in the RAM is going to contain the data for this JUMPIF instruction, and that data in effect is the actual address that we want us to jump to. So we don't want to pick up that particular byte as the next instruction, because it isn't, that's the data from the previous instruction. Okay, so we need to add 1 on in order to ensure that the next time we come round we're actually pointing at the proper address in RAM. So it's really down to the fact that this jump instruction is going to be 2 bytes long. There's going to be the instruction and then the data. So also we can see here that the existing contents of the instruction address register are going to be enabled onto the bus, and then they're going to get into the memory address register, so that we're pointing to the first address in the RAM. Okay, and also the accumulator is going to be set, so we're setting the accumulator with this new bus this new value here. So really that point there again is just getting ahead of the game as far as the next fetch cycle is concerned. So let's go on to step number 5. So when we go to stage 5 here, we can see that this line here is going to go live. So this is going live. So it means that the contents of the accumulator are going to be enabled onto the bus. So remember, the accumulator is going to contain the address of the next instruction. So we had added one on, so we jumped over the data byte from the previous instruction, and we're now on to the next instruction. So if there isn't going to be any JUMPIF, then all will happen is this value for this address here will just head out to the instruction address register, ready to jump on to the next instruction. But now when we jump on to stage number 6, this is when we're going to make the choice. So the choice is going to be, do we just jump on to the next instruction, or do we jump somewhere else? And this is the jump somewhere else bit, and this is a choice that's been made. So let's go and have a look at that just now. So now if we're at stage 6, then this line here will be live. Now if we come down to the other two inputs to this AND gate, we can see that one of them here comes from the carry, or the A is larger, equal or Z. So this is the flags. So one of them comes from the flags. Now if it turns out that none of the flags are set, so if they're all 0, then we're just going to get a 0 coming out here. In that case here, that there's not going to be any output to this AND gate. So that means that the instruction address register is going to be determined by this line here, which is the accumulator enable. So that would just be telling us that there's no flags have been set, therefore just continue to the next instruction. Okay, but if it turns out that one of the flags, say for example the 0 flag, had been set, then it's going to jump if that 0 flag is set. So if the 0 flag is set, that goes high. That means that goes high, that's high, and we're at stage 6, so that's gone high. So that means that the output is here is now high. So that means that the feed in from this OR gate won't come from this point here. It's going to come from this point here, which is the next address of the RAM, which contains the address that you're actually wanting to jump to. So in that instance there, then what goes on to the instruction address register isn't the value for that accumulator, it's going to be the value that's in the RAM, which is the next address in the RAM. So that's in effect the choice being made at that point there. Does the instruction address register contain the instruction for the next data instruction from accumulator, or does it contain the value from the next place within the RAM? Okay, so that's a choice that's been made, and whenever this 0 goes high, it's going to come from the RAM. So the next address within the RAM will contain the place that you actually want to jump to. So let's go up to the top level and we'll see this working. So let's put in our instruction. So it's going to be 0, 1, 0, 1, and let's say that the 0 has been set. So that's that 0 there. Now let's say that also that we're going to be jumping to memory location 15. So now we'll work through this. Nothing will happen for the first 12. And on the 12th one, you'll see here that we had this bus 1 goes high, because we know it's a jump if, and we know we're going to have to be potentially pointing to not the next place within the RAM which contains the data, we want to point to the one address beyond that, okay, which contains the next instruction. So also you can see here that the value of the instruction address register has been enabled, which is 0, and we're going to go to the next clock pulse, which will set that into the memory address register. Also that value for the accumulator has been, the 1 has been passed down through here, so now it's sitting in this accumulator. So really, whenever we work through the next steps, the choice is going to be, do we load up the instruction address register with the address that's in this accumulator, or do we load up the instruction address register from the next byte within the RAM? And that's the choice we're just about to make. So if we head on to get the next position, so we go up to our clock is now enabled, we can head back down in here and we can see we're on this position here. So at position number 5 we can say here that the accumulator has been enabled with the new value, and it's just sitting there, and whenever the clock set comes along it will get passed to the instruction address register. So let's go up to the top, and whenever we go to the clock set there, so that's the new value there, which would be position 1, okay, is now passed on to that instruction address register. So it's sitting in there, and as far as the instruction address register is concerned, that's the next instruction that we're going to use. So let's look inside the control section for the choice. So right now we're sitting in stage 5, and we can see here that the instruction address register is getting its value from the accumulator. But whenever we go into stage number 6, what can happen is this can be overwritten. So instead of the instruction address register getting its value from the accumulator, it can get its value from the RAM. It only gets value from the RAM if one of these gets set high. Okay, so if any one of these gets set high, the 4 bits, so the carry, the A is greater, the equal and the 0, any of those go high, this point goes high, this point goes high, therefore the value in the instruction address register will actually come from the RAM. So that gives a good indication as to how we make the choice between the value that's in the instruction address register coming from the accumulator or the RAM. But you'll note here that there's a little red line, so red lines should be warnings because that's really an error. Now I can't show you the full simulation run all the way through to stage 6, because when we jump to stage 6, the way it's set up at the moment, we're actually trying to change 2 things at once, and Logisim's not happy with that. So you might be saying, well, does that mean the design doesn't work? Well, no, the design works perfectly well, but because I've had to disconnect sections here in order to put inputs in to try and show you how the thing works, in doing so we're not able to run through the entire simulation. But once it's all connected up, then you will be able to see it working, and it will work perfectly well. But because it's a kind of chicken and egg here at the moment, I'm taking away sections of the control section so that you can make it makes it easier to understand each little part of the instruction set. But in doing so, in some of the simulations, and I'm not able to show you every single part of it, okay, but you will see it working once it's all built together. So the main thing to take out of this video is really in the control section here, being able to understand where we've made the choice. So now there's one other little factor we've got to take care of here. So we're back at the top level here, and you'll see I've actually changed this a little bit. I've shifted this register down a little bit here, and we've got an extra couple of gates here. So there's a gate here, and there's a little in here. It's just a little 1-bit memory. Now there's a reason for putting that in, and that is that if we were to look at the carry out here, well, generally what would happen is the carry out we just go through our little 1-bit memory, and then it would just feed back into the carry in. So in effect, carry out just goes back to carry in. But there was a problem with this, and the problem is that whenever we go through every single instruction, we're always going to be adding 1 on to this at this point here for the bus. So we add 1 on in order to ensure that we point to the next instruction. But in that process of adding 1 on in order to get to the next instruction, we're not actually interested in this carry in. We're only interested in the carry in whenever we're performing an ALU function. So this is a possibility of having an extra 1 coming in here during this fetch cycle. So instead of adding 1 on, we could potentially add 2 on. So that would give us an error. So in order to prevent that from happening, we've got this little AND gate in. So now in order for the carry in here to go high, it'll only go high whenever we're performing an ALU instruction, and it'll only go high at a particular point, and the point is going to be given by this input here, which is at the stage 5 of the ALU instruction. So really at the same stage as this flag set instruction, which we talked about just a minute ago. So whenever this goes high, it tells us that we're at the right point of the ALU instruction, and at that point there, then we can look at the carry in and we can use the carry in. But we won't be otherwise, we won't be interested in the carry in, and that carry in will be low. So it means that we don't have the potential of adding an extra 1 on whenever we do the fetch cycle. So that's one problem, but we run into a second problem as well, and that's what this little register's for. So let's go and talk about that now. So I've added a little temporary memory location here just to save the value of the carry. Now we've done that because we want to make sure that we've got the correct carry, and if we were to take a copy of the carry at stage 4 of the ALU, now we can get stage 4 of the ALU by connecting to this temp line because it goes high at stage 4. So if we take a copy of that, then we know when we get to stage 5 of that ALU instruction, we indeed have the right carry value available to us. If we didn't have this, then there's a potential for that carry value to change, and if it changed, then we would be feeding in the wrong carry value. So this is really just added for a little timing issue. So that's the last of our jump instructions. There's only one more instruction to work through, and it's going to be an easy short one, and we'll get to that on the next video. So thank you for listening, and goodbye.